Going to continue taking a look into the severe weather threat for Thursday evening, afternoon, evening time, primarily focused on south central Illinois. That's where I'm seeing the most environmental factors for having supercell development. Both the GFS, both the GFS and the Euro model are showing this negatively tilted trough right in this general region right here. The GFS is a bit faster and weaker, and the Euro model is slower and more intense, but it's still there nonetheless. And so that's why a big part of the reason why, anyways, is why we're going to have a severe weather day in this region right in here. Looking at the low level jet, the GFS is a lot stronger than the Euro model. So, still having a bit of um, lack of confidence in how intense the supercells can be. Here's the GFS. It's showing like between 30 and 40 knots in Illinois. And then GFS, it's 25 to 30. So if the GFS does play out, then we will have a stronger day for supercell development. But right now, it just doesn't look like it could be as intense as we have seen in the past. With that in mind, though, taking a look into the bulk shear, which is just subtracting the 500 millibar winds from the surface, with not looking at any of the winds in between, all you need is 35 knots of bulk shear, and we have that on both the GFS and the Euro. Right now, it's ranging between 35 to 55 knots in southern Illinois on the GFS, and a bit higher with the Euro model showing 45 to 55 knots. So the environment is still there for supercells to occur, but we just need to have that low level jet being a bit stronger, pumping in more moisture into the lower atmosphere to have more of a outbreak like situation, which I don't think is going to happen right now. For GFS, the service base cape is really, really high. I don't see this happening, especially since the service base cape, it's not accounting for any of the boundary layer mixing that it happens with stronger winds at the surface. So this take this with a grain of salt right now. It's showing between 4,000 to 4,500 joules per kilogram. So really high. Don't see that happening though. What's even crazier is the mixed layer cape on Euro is showing even higher values, uh, at around 5,200 joules per kilogram. So I really think that this is over forecasted because when you have cape that high, it's looking more and more unlikely for something like that to happen. What does help favor some higher cape values is the lapse rates that are both being shown on GFS and Euro. Right now, looking at between 8.5 and 7 degrees Celsius per kilometer. So, pretty steep lapse rates on the GFS, and the Euro model is a bit higher, looking at 8 to 8.5 in southern Illinois. So, we could have a bit higher cape than what you would like to see in terms of safety, but I really don't think it's going to be as high as we're looking at for service based and mixed layer on both of the global models. Now, looking at the supercell composite from GFS, it's showing a bit of a stronger signal for southern Indiana to have the strongest probability for supercells, but I still think, based on all the things that we've looked at, I still think that Southern Illinois is where it's going to be at primarily. So let's take a look. Let's just take a look and see what is shown in Indiana, and just shift it to the west a bit in our imagination. So right now, something that stands out to me the most is how the winds, they're pretty uniform westerly once you get to about 700 millibars. What we need to have for intense supercells that drop a lot of tornadoes is a strong uniform turning with height. So we need to have, like, for example, a south southeasterly wind at the surface, and then a uniform, subtle, and just consistent turn to westerly up at the anvil layer, which is the EL or equilibrium level. So that is one of the biggest things that stands out to me. Another thing too that stands out is this elevated mixing layer here, and that's going to be helping the mixing needed in the mid levels to have supercell develop. One last thing that sticks out to me as well is the ship or the significant hail parameter. For the strong indicator of having large hail, we need to have that ship number between 1.5 and 2. Right now it's 4.1, which is a very, very strong indicator of having some sort of large to very large hail. We can't forecast exactly how large it is, but what that parameter shows is if the environment is capable of dropping hail, then it has the possibility to be greater than 2 inches in diameter. And as you can see on the sounding analogs, there is a lot of matches for having significant hail with this type of setup with all these matches right here. And then there's also 81 loose matches with 84% of those having significant hail. Um, there's not as many supercell matches or loose matches showing a tornado. So that is another thing too that I look at, just looking at the past history of an environment like this. That helps me forecast for having a large hail day and intense downdrafts as opposed to a tornado focused threat.